In any right triangle, the two non-right angles are complementary, meaning they always sum to 90 degrees. If we know one angle is theta, the other must be 90 minus theta. This simple geometric fact creates a powerful relationship between trigonometric functions. Because these angles share the same sides but from different perspectives, their sine and cosine values are deeply linked. What is opposite for one angle becomes adjacent for the other. We call these linked pairs cofunctions. Notice that the sine of theta is the ratio of the opposite side over the hypotenuse. Simultaneously, the cosine of the complementary angle uses that exact same side as its adjacent. Therefore, sine of theta equals cosine of 90 minus theta. This is the core cofunction identity. The co in cosine literally stands for complementary. It tells us that the function of an angle is equal to the cofunction of its complement. This applies to sine and cosine, as well as other pairs. The pattern continues with tangent and cotangent. Since tangent is opposite over adjacent, and cotangent is adjacent over opposite of the complement, they yield the same ratio. Tan of theta is always equal to the cotan of 90 minus theta. Finally, we see this with secant and cosecant. These reciprocal functions follow the same complementary rule. Understanding these three pairs, sine-cosine, tangent-cotangent, and secant-cosecant, is essential for simplifying complex trigonometric expressions and solving equations efficiently. To keep these straight, remember that every co-version of a function is just the original function applied to the complementary angle. This symmetry is one of the most elegant parts of basic trigonometry. Let's look at a numerical example. Since 30 and 60 are complementary, the sine of 30 degrees must equal the cosine of 60 degrees. Both values are exactly 0.5, confirming our identity works perfectly. We can use this to solve equations. If sine of one angle equals cosine of another, the angles must be complementary. We set the sum of the two expressions to 90 degrees and solve for the unknown variable x. By subtracting 30 from both sides, we find that 3x equals 60. Dividing by 3 gives us our answer x equals 20 degrees. This technique is much faster than using complex addition formulas. What about fractions? If we have tangent of 15 divided by cotangent of 75, we can convert the denominator. Since 75 and 15 are complements, the cotangent of 75 is simply the tangent of 15. The expression simplifies to tangent of 15 divided by itself, which is 1. Recognizing cofunctions allows us to cancel out terms that look different but are numerically identical. In calculus and higher math, we often use radians. The identity remains the same, but we replace 90 degrees with pi over 2. Sine of x equals cosine of the quantity pi over 2 minus x. Be careful! The identity only works between a function and its specific cofunction. Sine of theta is not usually equal to sine of 90 minus theta. Always ensure you are switching between the correct pairs. To summarize, cofunctions link the ratios of complementary angles in a right triangle. Whenever you see a co- in a trig name, think complementary. This relationship is a fundamental tool for simplifying and solving trigonometric problems. Here is a quick challenge: if secant of 40 degrees equals cosecant of y, what is the value of y? Since they are cofunctions, y must be 90 minus 40, which is 50 degrees. Thank you for watching. Generated by Vision Solve AI.